Howdy folks. This video is for my Precalculus class, and this morning I introduced you guys to the 6 main trig functions, and we had to move pretty fast, so I was concerned that maybe some of you didn't really catch on, or maybe you'd want some kind of reference to go back to. So I thought what I would do is just kind of review what we talked about this morning, and that way you can go back to this video if you have to, and it'll help you. It'll help you with the homework. So the first thing we talked about is converting between degrees and radians. Okay, so converting between degrees and radians. And what I said is that if you want to go from degrees to radians, that you would multiply whatever you have in degrees, you would multiply it by pi over 180. And here's an example. Let's say that you have 81 degrees, you have an 81 degree angle. You would then just multiply that by pi over 180. And so, 81 degrees times pi. By the way, technically this is 180 degrees. And because we have a degrees in the numerator, and then a degrees in the denominator, the degrees would cancel. The degrees actually cancel. And then 81 times pi is 81 pi over 180. And then this can be reduced. And so let's see here. 9 goes into 81. And so we would have 9 pi over 9 goes into 180 for 20. And so this would reduce to 9 pi over 20. So an 81 degree angle is the same thing as a 9 pi over 20 angle. Okay? So that's how you convert from degrees to radians. Okay? If you want to convert from radians to degrees, okay, you would multiply your radians by 180 over pi. Okay? And so then let's say that you had a 2 pi over 15 angle. So your angle measure was 2 pi over 15. You would just multiply that by 180 over pi. And I'm not going to cancel the pi right now so that you can see, because I did that in class, and I don't know if that confused anybody, but let's go ahead and multiply 180 times 2. 180 times 2 is 360. And then, of course, we're going to bring over the pi times pi over. On the bottom here, we'll have 15 times pi. Now you can clearly see we've got a pi in the numerator, we've got a pi in the denominator, so they just cancel each other out. And so it would be 360 over 15. Now 15 will go into 360. Let's see, what is it? 20. Let's see, 150, 24 times. Okay, so 24. So this would be the same thing as 2 pi over 15 would be the same thing as a 24 degree angle. Okay? All right, so that's converting between degrees and radians. Now, the worksheet that I gave you, the problems that I gave you, all the radians and degrees are kind of convenient numbers because they're all on the unit circle. So 30 degrees, 3 pi over 4, that kind of stuff. So should be a lot easier even than these two problems that I've just done here. All right, so now let's talk about, that was the first thing we went over, was converting between degrees and radians. Now let's talk about the 6 trigonometric functions. Okay, 6 trig functions. Okay, and you'll probably want to have a unit circle close by while you're watching this video, because I don't have the unit circle drawn up here, but I am going to refer to the unit circle maybe once or twice, and I want you to be able to know where I'm getting these numbers from. So the 6 trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. Okay? And the way we would write these, if we have some arbitrary angle, if we have some angle measure here, and with a variable we would call the angle, we're going to call it angle theta. And like I said in class, theta is kind of like a variable like x or y or something like that. Okay? But theta, the Greek letter theta, is often used to represent a variable for an angle measure. And so that's why we're using theta. And so when we write these functions mathematically, we don't write the whole word, we only write 3 letters. So sine is written as sin, but we say sine of theta, okay? And when I say of, what I mean is sine is a transcendental function, which means it doesn't follow the normal rules of algebra, or at least not inside the function. It's a specialty relationship. And so when I say sine of theta, and then you may say, well, are you adding theta? I say, no, I'm doing sine of theta. And you say, okay, well, is that like multiplying theta? No, I'm not multiplying theta. Sorry, I'm doing sine of. So sine is its own operation. Okay, you got adding, you got subtracting, you got multiplying, dividing, you got exponents. Well, we're going to sine this. Okay, so let's say that theta was equal to 30 degrees. Well, 4 times theta would be 120 degrees. Okay, but when I apply a trigonometric function to theta at 30 degrees, it like transforms into a length instead of a degree angle. Okay, because sine is giving a relationship between an angle and a distance. So when I apply the conversion of sine to an angle measure, the output is a distance, not an angle measure. Okay, incidentally, sine of 30 degrees is 1/2. Okay, so and the reason for that is if you have a 30-degree angle, sine is the opposite measure. If you have a 30-degree angle, sine is the length of the opposite side, assuming that the hypotenuse is 1. And so a triangle with a 30-degree angle and a right triangle with a 30-degree angle and a hypotenuse of 1, the side opposite of the 30 degrees would be 1/2 long. Okay? And that's what sine does. Sine just tells you the length of the opposite side of an angle in a right triangle. Or it tells you the proportional size of the opposite side relative to the hypotenuse. Okay? So, it can be a little confusing, but the more you do it, the more the more you can do it. This is one of those things where, like at first, you kind of understand what you're doing, and you know how to do it, and then you do it 100 times, and then after you've done it 100 times, you're like, okay, now I understand what it is, but then it's hard to explain to other people without having them do it themselves. Okay? So we would write sine of theta, we would write cos for cosine of theta, tan for tangent of theta, csc of theta for cosecant, sec of theta for secant, and then for cotangent, cot of theta. And when you put the theta right next to the sine and the cosine and everything, you say of. So sine of theta, cosine of theta, tangent of theta. Okay? And in this particular case, sine on the unit circle is simply, because all the right triangles on the unit circle, all the right triangles created by the terminal side have a hypotenuse of 1, because the hypotenuse on the triangle is the terminal side, and it's a radius, and the radius of the unit circle is 1. So sine is simply the y-coordinate. It's the y-coordinate of the dot at the end of the terminal side. So you got this line over here, okay? You got the terminal side. Wherever that terminal side, it's 1 long, wherever it touches on the circle, the y-coordinate of that dot is sine, okay? Cosine is the x-coordinate, okay? And so if we were to say, what is sine of pi over 4? Well, if you look on your unit circle, pi over 4, which you got this dot, and you got 3 dots here in the middle, right? And the one in the middle at a 45-degree angle, that's pi over 4. And you'll see that the y-coordinate at that point is square root of 2 over 2. So sine of pi over 4 is square root of 2 over 2. Cosine is the x-coordinate. Cosine of pi over 4 happens to be the same thing. It's square root of 2 over 2. Because at pi over 4, x and y are the same. Square root of 2 over 2. Okay? Now, once you can get sine and cosine, once you are familiar with identifying sine and cosine, from that point on, tangent, cosecant, secant, and cotangent are a piece of cake. Because tangent is sine over cosine. So basically, you're just going to plug in whatever sine of theta is and divide it by whatever cosine of theta is. And since sine of theta is the y-coordinate, it's y over, and cosine is the x-coordinate. Tangent is the same thing as the y-coordinate divided by the x-coordinate. Okay, so, so tangent of, let's say, tangent of, let's do pi over 3, okay? If you look at pi over 3 radians on your unit circle that you have in your notes, okay, you'll see that the sine is square root of 3 over 2, and cosine is 1/2, right? So the tangent of pi over 3 is square root of 3 over 2 over 1/2. However, that's not how I want you to write it. Okay, you need to simplify this. You can write it as square root of 3 over 2 divided by 1/2. Now, divided by a fraction, when you divide fractions, that's the same thing as, you got the square root of 3 over 2, and then you change this to multiplication, right? Well, let's use the dot instead of the x. I don't want to confuse anybody. All right, so square root of 3 over 2 times, so keep, change, flip. So this is going to flip over to 2 over 1, okay? And this is going to be 2 times the square root of 3 over 2 times 1 is 2. And guess what's going to happen here? The 2's are going to cancel. And now the answer, tangent of pi over 3, is just the square root of 3. Okay? So tangent of pi over 3 is the square root of 3, because we did sine divided by cosine. Okay? All right. Cosecant, same kind of idea. Cosecant is related to sine. Cosecant is the reciprocal of sine. So it's 1 over sine of theta. Secant is related to cosine. So secant is the reciprocal of cosine, so it's 1 over cosine of theta. So to get cosecant or secant, you would first, so if you wanted to know what cosecant of 2 pi over 3 is, you would do 1 over sine of 2 pi over 3. And sine of 2 pi over 3, you go to your unit circle, you go around to 2 pi over 3, and you'll see that the y-coordinate at 2 pi over 3 is square root of 3 over 2. And so this is 1 divided by the square root of 3 over 2, but really this just means the reciprocal of the square root of 3 over 2, which means that it's 2 over the square root of 3. Now this is not an acceptable answer. So we would multiply by we're going to do what's called rationalizing the denominator. To rationalize the denominator, you multiply by the denominator, a fraction with the denominator on the bottom and the denominator on the top. 2 times the square root of 3 is 2 square root of 3. Square root of 3 times square root of 3 is 3, and that's your final answer. So cosecant of 2 pi over 3 is 2 square root of 3 over 3. You could do the same thing with secant, only you would use cosine in the denominator instead. Cotangent is the same thing as the reciprocal of tangent, 1 over tangent. Or, since tangent is sine over cosine, the reciprocal of sine over cosine is cosine over sine. And so if you wanted to know what cotangent of pi over 6 is, well, then you would just put the cosine up top, square root of 3 over 2, divided by sine of pi over 6, which is 1/2, which happens to be the same thing as we did this just a minute ago. It winds up being the square root of 3. Okay? All right, so now note here, since cosecant is 1 over sine, and sine is simply just the y-coordinate, that means cosecant is just whatever 1 over the y-coordinate is. Secant is 1 over the x-coordinate, and cotangent is x over y. Okay? That's what I went over this morning. I hope this helps a little bit. Sorry, there's one more thing I got to go over. The triangle. So I'm going to leave those up there. And what we're going to talk about here is, let's say that we have a right triangle. Looks like this. Okay. And let's say that it has one of the legs is 4, one of the legs is 3, and the hypotenuse is 5. Okay. And we want to know this angle right here. We'll call this angle theta. And let's call this angle up here angle rho. Okay, that's a Greek letter, rho. And what I'm going to show you here is I want to show you the trig functions when just dealing with triangles, when you're not dealing with the unit circle, just triangles. Okay? Now you've already learned a while back that sine is equal to opposite over hypotenuse. Okay? And so this angle right here, angle theta, sine of angle theta is the opposite, that's the opposite, over the hypotenuse. The opposite length, the opposite of angle theta, the length is 3. Okay? Oh, and what we're going to do is we're going to call this the radius, because that's the radius of the circle, right? And then we're going to call this distance x, and we're going to call this distance y. The opposite distance is y. So sine really is just whatever y is over r. Y over r, and in this case it is 3 over 5. Cosine is adjacent. Oops, I do that frequently. Adjacent over hypotenuse, which is, this is the adjacent side here to theta. Theta is touching this leg. So that's x over the hypotenuse, r, which will be 4 over 5. So in this particular triangle, based on just this angle, sine is 3 over 5 and cosine is 4 over 5. All right, tangent is opposite over adjacent, which is the y side over the x side. Y over x, which is going to be 3 over 4. Cosecant is 1 over sine, right? Making it the reciprocal of sine, which would flip the opposite in the hypotenuse. The reciprocal of opposite over hypotenuse is hypotenuse over opposite. So the hypotenuse is r over opposite is y. So in this case, that would be 5 over 3. secant, now note, all we really had to do for cosecant is go up to the 3 over 5 and flip it over 5/3, because cosecant is the reciprocal of sine. So we could go to secant. Secant is the reciprocal of cosine. Cosine is 4/5, so secant is going to be 5/4. Okay, but let's look at it. Let's write it out. 1 over cosine, which is going to be, cosine is adjacent over hypotenuse. So now it's going to be, it's going to be hypotenuse over adjacent. Hypotenuse over adjacent, which is r over x, which is 5 over 4, which we already predicted based on what we knew about cosine is 4/5. And lastly, cotangent is the reciprocal of tangent. Okay, so instead of being opposite over adjacent, it's going to be adjacent over opposite. So instead of being y over x, it'll be x over y, which in this case would be 4, wait, hang on. Oh yeah, here we go, 4 over 3. So 4 over 3, which is the reciprocal of tangent. Tangent was 3 over 4, cotangent is 4 over 3. But something we didn't cover in class, which I now want to show you, is this. Is the next thing I wanted you to do with these triangles on the work that I gave you to take home, is that after doing all of the theta functions, I wanted you to then do all the rho functions. So now with rho, this is no longer, the 3 is no longer opposite. 3 is now adjacent. And so that makes it x instead of y. And the 4 is now actually the opposite angle, making that one y instead of x. The hypotenuse is still the same. It's still the r equals 5. Okay? So now when we go through here, we're going to change these. I'm going to do them in a different color. I'll do them in red. We'll do them over here. So sine of rho, okay, well that's probably, that looks pretty terrible. Fix that. So sine of rho is going to be y over r. Y is 4, r is 5, so 4/5. Cosine of rho is going to be x over r, adjacent over hypotenuse. And adjacent to rho is 3, and hypotenuse is 5, so 3/5. If you're starting to recognize a pattern here, there is a pattern. Then tangent of rho is going to be opposite over adjacent. And for here, opposite is 4, adjacent is 3, so 4/3. And then cosecant of rho is the reciprocal of sine. So instead of 4/5, it's 5/4. And then secant of rho is the reciprocal of cosine. So instead of 3 over 5, it's 5 over 3. And, you know, you can get that from r over x. R over x, 5 over 3. And lastly, cotangent of rho is going to be the reciprocal of tangent, which is x over y. X over y is 3 over 4. Tangent is 4/3. Reciprocal is 3 over 4. Okay? And here's what I want to show you. Something very interesting. Do you notice that when we switched the angles, when we went to the other angle on the other side, sine and cosine, cosine of theta is the same as sine of rho. That's a predictable pattern. And sine of theta is the same as cosine of rho, 3/5, right? Also note that secant of rho is the same as cosecant of theta. Cosecant of rho is the same as secant of theta. tangent of rho is the same as cotangent of theta, and cotangent of rho is the same as tangent of theta. So arrows are all on top of each other. Okay? And that's because these angles are related to each other in a reciprocal fashion. Okay? So I hope that this helps you understand how you're supposed to do the front and the back of this assignment for pre-calculus. Okay? All right. Well, have a good day. I hope this helped.